Drop a like and do share. Leave your comments and do not forget to subscribe for more videos.
Let us proceed with the chapter Hydrocarbon. In the previous video, we have studied about the introduction of the hydrocarbon. In this chapter, we will be doing with the alkanes, and we will cover the general properties about the alkanes. In next video, we will do about preparation, and after that properties, physical and chemical, and lastly the conformers. So let's proceed. Alkane. Okay, as you can clearly see, this is methane, ethane, propane, 1 carbon, 2 carbon, 3 carbon. Okay, only carbon and hydrogen are there, 1 carbon and 3 hydrogen. So we'll do with the basics of alkane. Okay, so as we have done earlier, alkanes are saturated hydrocarbon. Why saturated? Because they have the maximum number of hydrogen that can be attached to any carbon atom. Okay, and secondly, why they are called alkanes? Because they have only single carbon-carbon bond. Okay, and they are also known as paraffins, and they undergo some reaction at very high temperature and pressure. And we divide alkanes into two, either open chain or cyclic. So open chain is also known as acyclic, means not cyclic, and cycloalkanes is also cyclic because they will form a ring. As you can see, this is cyclohexane and this is normal butane and butane. There open chain, this is ring. Now the open chain alkane, they have a general formula of CnH2n plus 2, where n represents the number of carbon atom. So just by putting the value of n, you can easily find out the formula for open chain alkanes. For example, put C is equal to 1. So when n is equal to 1, 2n plus 2 will be 4. So methane CH4, 1 carbon atom and 4 hydrogen atom. Similarly, put value C is equal to 2. So you will get C2 and 2n plus 2, 4 plus 2, 6, H6. Okay, and you can easily draw also, like carbon and carbon, they will have single bond and all other valency will be satisfied by hydrogen. So you can clearly see that each of the carbon atom will have 3 hydrogen atoms. Okay, so C2H6. Similarly, if we put n is equal to 3, then we will get C3 and 2 into 3, 6 plus 2, 8. So C3H8. Again, we can draw the structure: carbon-carbon single bond, and then attach the maximum number of hydrogen with each of the carbon atom, so that their valency of 4 is satisfied. 3 here, already 2 valency is satisfied, so only 2 hydrogen is required. Again here you need 3 hydrogen atoms. So total is 8. Similarly, you can do for any number of carbon atom. Okay. Now the cycloalkanes. Okay, so cycloalkanes, they will have a general formula CnH2n. Okay, because the end of the chain, they have got a bond, so that's why it is 2 hydrogen atom less then the acyclic or open chain alkanes. Okay, for example, take cyclopropane. So 3 carbon atom attach these three, and since all the carbon atom they have two valency satisfied, so they will require only two hydrogen atom. Okay, similarly cyclobutane. This is 1, 2, 3, 4. Okay, and then 2, 2, 2. So for propane 3 carbon, so C3 and 2N H6 246. Similarly for butane, cyclobutane C4 H8. Okay, this is the normal structure which we draw. Okay, and this is the 3D representation. Okay, now let's study what is the structure, how they will look like. Like we have seen in the previous example. Okay, they have this kind of structure. Okay, so it's a 3D structure, tetrahedral. If you observe each of the carbon, okay, it is a tetrahedron. So we'll discuss about this structure. Okay, so let's start with the first member of the family, that is the methane. Okay, that will provide the simplest structure. Okay, so carbon and then 4 hydrogen atoms are attached to it. Okay, so if you see, like carbon has got how many electrons? Okay, so carbon, its atomic number is 6. Okay, and its configuration is 1s2, 2s2 and 2p, 2,4, 2,6, 2p6. If you go by valence bond theory, you must have studied about valence bond theory in your chemical bonding chapter. Okay, if you have not, then please refer that chapter. Okay, as we can see that only 2 of the orbitals of p are vacant, so it should ideally form only 2 bonds, but it actually forms 4 bonds. So how it can be explained? That this is the ground structure. Okay, so this s electron will get excited to and go to the p orbital. So in the excited state we will have this configuration. 1s will remain at s, and one of the electron from s orbital will get excited to p orbital. So earlier there were 2, now we'll have 3. Okay, so now we have 4 vacant orbitals, so they can form 4 bonds. Okay, so these 4 orbitals s, this is 2s, this is 1s and this is 2p. So they will overlap and form bonds. So ss bond is always stronger. So ideally ss 2s and 1s of hydrogen, they should form a shorter bond length, and then the 2p overlap with carbon and 1s of hydrogen. But what we observe is that all the bonds of CH in methane, they are of same length. So this is only possible when all these 4, they are equivalent, and this can happen only when they get hybridized and form a hybrid orbital. So instead of s and p, they mix up and they lose their identity as s and p, and they form a hybrid orbital. Okay, s and px, py and pz, they will mix up to form 4 sp3 hybridized orbital like this. And since they are identical, so their bond length will be similar. Okay, and since it is 4, so it will form a regular tetrahedron. Okay, and the bond angle, like between these any two bond angle, will be approximately 109.5 degrees. So for any regular tetrahedron, you will generally find this degree pattern. How we represent it on paper, like it is the 3D structure. So it's not possible to represent the 3D structure as it is on paper. So we convert and make a convention so that it could be represented on paper that as 2D structure. So we'll put two bonds. Okay, two bonds in a plane of the paper, and we will represent it by a line. So carbon, hydrogen, then line. Okay, these two, they are on the plane of the paper. Okay, so this HCH bond, they are on the plane of the paper. Then there is wedge. This wedge, that means it is out of the plane of the paper. It's coming towards the viewer, and this is known as dash. Okay, that goes inside the plane of the paper, that is away from the viewer. Okay, so this clearly gives us the picture how things are arranged, okay, in 3 dimension. So like here it is H, all H are equivalent. Okay, so there will be no problem. But when instead of H it is any alkyl group like CH3 or C2H5, then we'll have to mention. Okay, so here the important points were the alkanes will have sp3 hybridization, and they will have a tetrahedral structure. Okay, and their bond angle will be 109.5 degrees. Okay, so let's start with the nomenclature of alkanes. We have studied in great detail about the nomenclature in previous chapter. You can refer those videos on nomenclature. We'll just do the basic stuff over here and just kind of a revision. So first, there are certain rules which should be followed before naming. Okay, so first rule is selecting the longest carbon chain. Okay, so it's pretty simple. Okay, simple it is, like you have to select the longest carbon chain, so that will become the word root. Okay, so like you can see, the longest carbon chain over here is of 9 carbon atoms, whereas this one is 8. So we will not go by this, we'll proceed via this one, and this will become our longest carbon chain. Okay, and this will become the word root. If you recall, the any name will have 3 parts. Main is the word root, then we have prefix that basically contains the substituents. These 2 groups, they are the substituent which are attached to the main carbon chain, and then suffix. In this case our suffix will be ane. For alkane the suffix is ane. Okay, so next is the position of the substituents. Okay, so it's about the numbering, how numbering should be done. So we should number such that the substituents, these, they should get the lowest possible number. Okay, so like if we proceed via this, so we have 2 and 6, and then we have 8 and 4. Okay, so we should proceed with that so that they could get lowest possible number. So in this case lowest possible is 2. Then next is lowest set of locant rule. Okay, if there are two or more than substituents, then we should number from that end so that the substituents should get the lowest set of locants, or we can say the lowest sum of locant. Okay, it is also known as lowest sum of locant rule. Simple is like number it and then add the add the position of the locants. Whatever gives you the lowest number will be preferred. Okay, for example, if you proceed from this side, you will get 2, 2 and 4. Okay, and if you proceed from this way, then you will get 2, 4, 4. So it's clear this is smaller than this one. Either you can compare or you can add whatever you like. Okay, so it should be smaller set of locant or a smaller sum. Next is if more than one substituent at a place, then we'll use some prefix. For example, for 2 we use di, for 3 we use tri, for 4 tetra, and so on. Okay, and we have to also mention their position, like here 2 and 4. So we need to mention their position, and the numbers will be must be separated by a comma. Okay, and number and alphabet, they must be separated by a dash. Okay, so these two are important. Numbers are separated by commas, and number and alphabet, they are separated by dash. Okay, and then we need to use appropriate prefix, like for 2, di, and so on. Okay. Next, if different substituents are present, then how we should proceed, which should be preferred. Okay, like should we go whichever the substituent comes first, or is there anything else? So here we should follow the alphabetical order. Okay, so like E comes before M, so E will be represented first and then M. Okay, so if we see 1, 2, 3, 4, 5, 6, 7, 8, this is our word main carbon chain. This will form the word root. For 8 it is off. Okay, so you can proceed any side, this way or that way, both will have the number 3. Okay, but we'll deal about this problem in next rule. Okay, why we proceeded from left side, why not from the right side? Okay, now these have got the equivalent when, like in this example, when the substituent, they have got the equivalent position, like this is also at the same position 3, and if we proceed from here, and this will get 6, and if you proceed from right side, this will also get number 3 same, and this will get 6. So positions are equivalent. If we compare 3, 6, this is also 6, 3. Okay, so position is same. So where we should go, whether by left side or right side. So in this case, since the position are equivalent, then numbering will be done in such a way that the substituents whose alphabet comes first should get the lowest number. Okay, so we'll proceed from this side, not from the right side, because if we proceed, then ethane comes first in alphabetical order. Okay, and that should get the lowest number. So this is right, this is not. Okay, so this will become 3 ethyl and 6 methyl octane, not 6 ethyl. Okay, and you should also see that we have always written the substituents in alphabetical order irrespective of their position. Okay, like 3 ethyl and here 6 ethyl. Okay, so first the substituent, this should be written in alphabetical order. Okay, and with the appropriate number. A number is related to the lowest locants, and this substituents, they should be written in alphabetical order. Okay, now if we have some complex substituents, then like this one, this is complex substituent, you cannot simply write its name, so we will write the name of the main carbon chain, okay, separately, and separately mention about this complex substituent. Okay, and we should first mention its position, that its position is 5, you can clearly see. Okay, and then we assume this as a separate chain of alkyl, and then we'll number it. So the carbon which is attached to the main carbon chain will get number 1, and then we will follow the same rule. Find the longest carbon chain. Here the longest carbon chain is of 3. Okay, 1, 2, 3, and then write its name. So it is at 2 position, there are 2 methyls, so it is 2,2 dimethyl, and then 1, 2, 3, so propyl. So 2,2 dimethyl propyl, and then we have to mention its position. Its position is 5, and this thing should be written in bracket. So this shows that it is a complex substituent, and then the usual, it is 9 carbon chain, so non and ane suffix. So this was all about the nomenclature. Okay, you can revise about the nomenclature from our earlier videos in which we have covered it in great detail. Okay, thank you.